Solving quadratic equations. We've been solving quadratic equations and we've learned two methods so far. First, we learned graphing. Here I've graphed x squared plus 2x minus 8 equals 0, and the solutions are negative 4 and 2, because by graphing I can see where the parabola touches the x-intercept. I could have also used factoring to solve that equation. Here I factored x squared plus 2x minus 8 equals 0 into the factors x plus 4 times x minus 2. And by using the zero product property, I set each factor to 0 and solved the equation and found the answers to be negative 4 and 2, just like when I graphed. Another way to solve quadratic equations is the quadratic formula. This is the quadratic formula. Negative b plus or minus the square root of b squared minus 4c all over 2a. Today we're going to talk just about the discriminant, b squared minus 4ac. The discriminant is the expression under the radical sign in the quadratic formula. Here again is the quadratic formula. Today we'll be talking just about the discriminant, b squared minus 4ac. We'll be putting in values for a's, b, and c in our quadratic equation to calculate the discriminant. Once we've calculated a number for the discriminant, we can determine how many solutions the equation has by the type of solution the discriminant is. So if the discriminant is a negative number, we know there's 0 roots. If the discriminant is the number 0, it has 1 root. And if the discriminant is a positive number, it has 2 roots. So here's some examples demonstrating this. In our first example, by looking at the graph, I see that the graph touches the x-axis at 2 spots. So this has 2 solutions. So my discriminant should be a positive number. So let's calculate my discriminant. A is equal to 1. B is equal to 2, and C is equal to negative 8. Now that I identified A, B, and C, I'm going to plug these values into this b squared minus 4ac to see what type of number I get. So b squared is 2 squared, which is 4. So my b, no matter if I square a negative or positive number, is always going to be a positive number. Then I like to write minus 4, and then in parentheses, I go ahead and multiply a and c together before I write it in. So 1 times a negative 8 is a negative 8. So 4 plus 32 is 36. 36 is a positive number, and since it's a discriminant and positive, I know there's 2 solutions. So that was correct. In my next example, x squared plus 6x plus 9 equals 0, I see that the graph is just touching at 1 point on the x-axis. That means there's 1 solution. So the discriminant should be equal to 0. Let's see if that's true. A is equal to 1, B is equal to 6, and C is equal to 9. So I'm going to substitute these values in here to determine what my discriminant value is. So b squared is 6 squared, which is 36. And then I always write minus 4 and then parentheses. I'm going to take a times c, which is 9, and write it in there. So 36 minus 36 is 0. So my discriminant is 0, which means I have 1 root, and that's correct. My next example, x squared plus 2x plus 4 equals 0. Here I can see by the graph I have no solutions, so I'm anticipating that my discriminant will be a negative number. So let's go ahead and see if that's right. A is 1, B is 2, and C is 4. B squared, 2 squared is 4, minus 4, parentheses, A times C is 4. 4 minus 16 is negative 12. And indeed, my discriminant is a negative number, indicating there are no roots or no solutions. State the value of the discriminant and determine the number of roots. So go ahead and try these two. So in our first one, 4x squared minus 2x plus 14 equals 0. I calculated the discriminant to be a negative 220. And when I graphed it to check it, I saw that I had no roots. And since it was a negative discriminant, that's what I had anticipated. 3x squared plus 10x equals 12. Well, to get started here, I first need to rewrite this and set it to 0. And once I do that, I calculate my discriminant to be 148, which is a positive number, so that would indicate 2 roots. And when I graph and look at my graph, I see indeed there were 2 roots.